Good day, everyone. Thanks for joining today's class. Today we'll be carrying out calculation that involve inductive reactance represented by X subscript L, and unit of inductive reactance is ohms, and also resistance represented by capital letter R, and the unit of resistance is ohms likewise. Now let's define some parameters. Impedance. Impedance is the total opposition offered by the alternating current circuits to the flow of electric currents. And we use capital letter Z to represent impedance. Now let's talk about the inductor, the inductive reactance. The inductive reactance is the opposition to the flow of currents offered by the inductor. Again, inductive reactance is the opposition offered by the inductor to the flow of currents, and also is due to the changing magnetic field in the circuit. That's why you have the inductive reactance. The unit of inductive reactance is ohms likewise. Let me define inductive reactance again. Inductive reactance is the opposition offered by the inductor to the flow of currents in the circuit, and is caused due to the changing magnetic field in the circuits. Now let's go to resistance. Resistance is a property of a conductor opposing the flow of current in the circuit, and it makes electrical energy to be converted to heat. When current is flowing and there is resistance, the electrical energy that is taking place in the equipment or the wire or the conductor will be converted to heat energy. Okay, now since it's combining the inductor and the resistor, you now have Z squared equals R squared plus XL squared. We don't have the impedance, we have the inductor. Let's write the parameters. Inductor equals 0.1 Henry. The unit of inductor is Henry. Resistance, we don't have it. Current, we have current to be 1.5 ampere. PD, potential difference will be 75 volts. This, what you're seeing here is the frequency F, which is the frequency 50 over pi hertz. And we have to look for the inductive reactance, XL. We're looking for XL, and we're looking for the resistance R. So the things we're looking for from here. Okay, I've written R before. Okay, now from here let's look for the XL because we don't have XL. The formula for the inductive reactance is 2 pi FL. Your XL now will be 2 pi times, what's the frequency? 50 over pi times the inductor, 0.1. Now pi cancel pi, 2 times 5 is 100. 100 times 0.1. To limit the rate at which we use calculator, let's change this decimal to fraction. We're having 100 times, write this 1 over decimal stand as 1. How many figure after decimal? 1 figure. Add 1 is 0. 0 cancels 0. You have your XL to be equals to 10 ohms. That's the value for the XL. Now from here, we can now go back to the formula Z squared equals R squared plus XL squared. So we're looking for the resistance. We have gotten the XL squared, the impedance now. We can also get it, but we don't know the resistance. We don't know resistance. And what you need to do is to carry out your substitution. Z squared equals R squared plus XL squared. Okay. Now we have the current. Don't forget that your V equals to IZ. V equals to IZ, and your Z, the impedance, through Ohm's law. In Ohm's law, that's Ohm's law. Ohm's law. Now let's make Z is subject of the formula. Z equals V over I. What's our potential difference? The voltage, 75 over current. That is 1.5. 1.5. Now you want to remove the decimal so that we can divide it. Shift to the front once, and when you shift to the front once, you add 1 is 0 to 75. Now 750 divided by 15 so that you can divide it. If you shift twice, you add 2 zeros, but we shift once to remove the decimal. 5 in 15, that's 3. 5 in 7, that is 1, remainder 2. 5 in 25, that is 5. Bring the 0 up. That's equals to 150 divided by 3. 3 in 3, 1. 3 in 15, 5. That is 0. Now your impedance is the overall position to the flow of current in the circuit is 50 ohms. The unit of impedance is also ohms. Now from here now, we can now look for our resistance. Now look for our resistance. Now let's make R the subject of the formula. And we have Z squared minus, take R across the cosine term to negative, minus R squared equals to, we're looking for R. Sorry, the resistance. Take XL across the cosine minus X subscript L squared equals R squared. Still the same thing when you write R squared equals Z squared minus XL squared. X subscript L squared. What's Z impedance? 50 squared minus XL 10 squared. To get our resistance, we are getting the inductive reactance to be 10 ohms, which is your R now. R squared equals 50 squared as 2,500. 50 squared is 2,500. That's 2,500 minus 10 squared, that's 100. Okay. Now let's do the subtraction. Let's do the subtraction. Your R squared equals 2,500 minus 100, that's 2,400. Okay. From here, you find the square root of both sides. Let's find the square root of this, square root of the other side. To cancel the square root, the resistance now. You press your calculator and get your square root, you have 48.99. 48.99 ohms, which is approximately 49 ohms. Okay, because 9 is more than 4, take it as 1, add it to this 8, add 1 to this here, 49 ohms. Therefore, our impedance, our inductive reactance, XL equals 10 ohms from the calculation. Our resistance equals approximately equals to 49 ohms from what we have to look for. That brings us to the end of the class. Please don't forget to subscribe to the channel for more updates, and also don't forget to leave your question in the comment section. Thanks for listening. See you in the next class. Have a wonderful day.